Today I'm going to be making plastic using completely edible, renewable and sustainable resources. Although they're edible, the end result isn't, so please, if you try this at home, don't eat the results. Now that we've got that out of the way, let's have a look at the ingredients we're going to use. Our main and most important ingredient is what's going to provide us with our monomer to create the plastic. It's potato starch. But we're going to need something to polymerize it. Now you've just been working with Molview and you should remember from that we need to break a couple of atoms off each end of a monomer in order for it to be able to bond to another monomer unit. To do that, we're going to use vinegar. Vinegar is an acid, and that will take those few extra atoms off the edge of our monomer units. Now I could just dissolve the potato starch and the vinegar in some water, heat it up, and get a really viscous liquid at the end of it, which would dry into plastic. However, that plastic would be very brittle and wouldn't have the strength that we're used to from plastics. So what I'm going to do is add a plasticizer. A plasticizer cross-links the polymer chains. It gives them the extra strength so that they don't fall apart easily. The plasticizer I'm using today is also fairly common in households. It's in cough syrup. It's called glycerin, and that will provide the extra strength that our plastic needs to survive. So I'm going to put all of those together now and hopefully end up with a nice plasticky result at the end of it. So I pre-measured the potato starch and I poured in some water to dissolve it. I do a little bit of stirring just to start the dissolving process and then add the vinegar. Stir some more and then I add the glycerin. The glycerin took a while to pour in, so luckily I've sped this entire bit of video up. It takes so long to pour in because it's incredibly viscous. Also, I'm heating it over a hot plate and I didn't want to hurt my hands, so I put some heat-proof gloves on. There's a lot of stirring in this part, so we're going to skip and have a look at the actual science of what's happening inside this beaker. Inside the beaker we have the amylose molecules floating around, having bits broken off them by the acids that are also in there. As the acids break parts off, they form these long amylose chains. I've simplified these chains so it's easier to look at the cross-linking that happens when the glycerin molecules start interacting with oxygens on each of the chains. Some time later. This was about 15 minutes later. There had been a lot of stirring by this point, so be grateful that we skipped through all of that. As you can see, this has gotten really viscous to the point that heating it any longer would be of little to no use, so I turn off the heat and enjoy this little close-up of the resultant glue. See how very thick and viscous it is. And I pour this out on some tin foil, smear it out so that it's a nice thin layer and allow it to dry. Once it's dried, it can then be re-softened and turned into material. You can even add food colouring to the plastic as you're making it so that you have a nice brightly coloured plastic when you eventually finish.